The table below has data from a 2009 Canadian Journal of Human Sexuality study. All right, there's a bunch of information present in the problem that's interesting to read. You can read that on your own, though. What I want to do is look at the last sentence in the problem, which I've indicated some key phrases here. It says, if one of the students is randomly selected, find the probability that the student is female or did use a condom. Okay, one student being randomly selected, they're asking us to find the probability, and we have the word or. These indicate that we should be doing the addition rule of probability. Remember, one item being selected, one subject being selected, that could be basic, addition rule, or conditional rule for probability. If it has the word or, we know it's addition rule. So, okay, we're aware that it's addition rule. Let's go ahead and fill out a probability statement then based on that idea. So we will say the probability of female or condom use, C. So F or C, F for female, C for condom use. That'll break down in a formula as the probability that the subject we select is female plus the probability that the subject we select used condoms minus the probability of the two categories blended together. So we will say females who used condoms. Okay, so that captures the idea. Now from there we should form three fractions. All right, so in all these fractions, the bottom is always going to be the total number of subjects involved in the study in this case. That's easy enough. But the top will correspond to what we have in this parenthesis here. So it'll be number of females in this case. Number of females. This next one will be number of subjects who used a condom. And this last category, we'll put them together. So it'll be the number of females who used a condom. Okay, so that blends the two categories together. All right, so now we have written out in words. The rest should be pretty easy. I've actually gone through the table and put some little indicators of the important numbers in the problem for us. To do this fraction, we have to figure out the number of females total in the study. Well, here's the female column. The total there is 1,201. So I would say that the number of females then is 1,201. And that'll be divided by the grand total. The grand total is this number here. That's the 2,145. 2,145. All right, to that I will add the number of subjects who used a condom. So let's see. Right here it says, did you use a condom the last time you had intercourse? It's either yes or no. Well, we want the people that answered yes to that, and that total number is 1,444. So 1,444 meet that criteria, divided by the total, again the grand total, 2,145. Remember that in addition rule of probability, if you're just grabbing one subject, these denominators will stay the same every time. Okay, then from there, we will have the last fraction, the total still being 2,145. And then we're going to put the number of females who used a condom in that top part of the fraction. Well, to figure that out, we have to figure out where these categories overlap. So if you look at this cell here that I put the little dot next to, 744, it has everyone in this column is a female, right? Every number here corresponds to females. And then across, if we go across in this row, all these people used a condom, right? So this is the intersection between the two categories. These are the females who used a condom, right? So 744. All right, and the last step, the final step then, is to go ahead and take our calculator and just perform the arithmetic in the numerator and then divide at the end by the 2,145. All right, so let's see, it's 1,201 plus 1,444 minus 744. When you're done with that, you get the value 1,901, and you will divide by that total of 2,145. And if we do that, we get 0.8862 ... So approximately 88.6%. percent.